So now we are going with the topic well-behaved preferences. So the first feature of a well-behaved preference is monotonicity. Monotonicity of preferences. It simply means more is better. Okay, so here we are talking the case of goods, not bads. If it is a bad, then more will be worse, right? In the case of bad, less is better. So in the previous class we discussed of the example pepperoni and anchovies. So anchovies was a bad, and when it is consumed more, the consumer is moving to a worse situation. So here we are considering goods only in this monotonicity concept, and here more is better. Considered more is better, and there is a condition that the situation where more is better have to be before the satiation. That is the optimum level of the consumer. If the consumer is in an optimal level, he won't consume more of any good, right? Because he doesn't want more. He is just in his utmost level of satisfaction at that particular point. So before any satiation sets in, more is better. Okay, so that is monotonicity of preferences. So for example, consider X and Y bundle. If this Y bundle is having at least one more good than the X bundle, consumer will strictly prefer Y to X. Okay, and next question, what does the monotonicity imply about the shape of indifference curve? It implies that they have a negative slope. Okay. And if we move down and to the left, we must be moving to a worse position. And if we move up and to the right, we must be moving to a preferred position. So down and left means to here. So if it is reaching here, down and left. Okay. So this is a worse position. And up and right, that means this part. Up and right means a better position. Okay, so if we are moving in an indifferent position, we must be moving either left and up or right and down. The difference curve the IC must have a negative slope. So that's it. If you want the verbal, the definition of the same, you can get it from here. Okay. This is what we discussed now. Monotonicity of preferences. More is better before any satiation sets in, before the satiation is established. That's what it means. And what does the shape of indifference curve according to the monotonicity? It will be in a negative slope. And these are the things we discussed now. Okay, so the next one is preferring averages to extremes. So with the help of the diagram we can go with the explanation. So I have written two bundles here, X1, X2 and Y1, Y2. So these are the extremes. So this is an IC and these are the extremes on this IC. Okay, taking the averages of both, where will it reach? So X1, half X1, half X2 plus half X1 plus half Y1, comma half X2 plus half Y2. So this is the average, weighted average of the two bundles. And this will be at least as good, that is weakly preferred or strictly preferred to the extreme bundles. The weighted average bundle has the average amount of good 1 and average amount of good 2, that is present in two bundles. So it therefore lies halfway along the straight line and connecting the X bundle and the Y bundle. So this is what it says here. That means, so I have written two extremes here. So this average bundle will be somewhat here. Okay, that is average bundle will be here, and it will be more preferred, at least weakly preferred. We have gone through this diagram in a previous class. So the shaded part, not shaded region, will contain the weakly preferred sets of consumption bundles. So if we have gone through the previous classes, this concept will be really clear for you, or else please watch the classes. And next is, so we are here we are going to assume this for any t, like any weight t between 0 and 1. So in the previous example, we just, the weight was considered as half, and here not half, any weight, like any t between 0 and 1. So this will be the condition for t here. And how it will be calculated? So for x1 and y1, tx1 plus 1 minus t, the rest part of t, into y1 minus, comma, tx2 plus 1 minus t y2 will be at least as good as or weakly preferred to x1 x2 or y1 y2. So this is the explanation for the same. So this is saying the same thing, along straight line connecting the two bundles. We have done this in this diagram. So consider this dark blue line as a straight line, okay, and this connects this to this average bundle. So here, instead of half, that below the example shows another t which is in between 0 and 1, lies between 0 and 1. So this is the way we can so this is very important. Next is, what does the assumption about preferences means geometrically? So here we are studying 3 graphs which are very important, very important. So let's check what these are. So the first graph is a convex, shows convex preferences, second convex preference, and third concave preference. So what is convexity first of all? So averages prefer to extremes. In this convexity that happens. So what is convexity? If we take any two bundles on the IC and take average of the bundles, then the average bundle will be as good as, or as good as means weakly preferred or strictly preferred. So anyway, that average bundle will be preferred to each of the two extreme bundles. So this, when graphically depicted, gives convex shape. Okay, so in the previous diagram, so these two extremes, when the average was taken, these two extremes, when the average was taken, we got it in the middle, right? So this will be preferred to. It can be weakly or strictly. Anyway, it is preferred to these two extremes. Okay, so this forms a convex preference. Okay, this is what a convex preference is said to be. And how this can be denoted, like this part. So this average bundle will comes in this shaded region. The convex preference will be coming in this shaded region. Okay. So this is what this example shows. This is shaded and this average bundle comes here, so that is a convex preference. That means to this bundles on IC, it is weakly preferred to the bundles on IC. Y1 or Y bundle or X bundle or whichever bundle which lies on IC, this indifference curve, this average bundle will be preferred to that. We have studied this in the first diagram of this, not first diagram, but one of the diagrams in the previous class. Okay, so this is just a continuation of that. And next, so the assumption about preference in geometrically, it means the set of bundles weakly preferred to x1 x2 is a convex set. So the bundles weakly preferred, that in the shaded region, are a convex set. For suppose that y and x are in different bundles, then if averages are preferred to extremes, all of the weighted averages of x and y are weakly preferred to x and y bundle. Okay, that's what we said now. A convex set has the property that if you take any 2 points in the set and draw the line segment connecting those 2 points, the line segment lies entirely in the set. So this is the explanation given in the above paragraph. And next, so about concave and not convex preferences. So what we think of the preferences that are not convex? One possibility might be something like a preference for ice cream and olives. So if I like ice cream and I like olives, but I don't like to have them together, considering my consumption in the next hour, I might be indifferent between consuming 8 ice creams and 2 olives, or 8 olives and 2 ice creams. But either one of these bundles would be better than consuming 5 ice creams and 5 olives. Okay, so these are kind of preferences depicted in this concave preference. Okay, this one. God, where is this? And this shaded part, okay, this will be preferred, and the average bundle, that is a bad. Okay, in all these cases, not convex, we only consider goods, and but here the average bundle is coming in bad, so it will be a worse position and the consumer is not interested in consuming that is equal amount of y1 and x, x is not interested by the consumer. He just want a preferred like 8 ice creams or 2 olives, not 5 ice creams and 5 olives. He can also have 2 ice creams and 8 olives, but not 5 ice creams and 5 olives. 5 ice creams and 5 olives means it will come in this point, in this average point. So the consumer is not ready for that.
Means that the consumer prefer to specialize at least to some degree and to consume only one of the good. So he does not want 5 equal amount of ice cream and olives. He just want at least 8 ice cream and 8 olives, or here 2 ice cream and 8 olives. So that's it. And next is one extension of the assumption of convexity is the assumption of strict convexity. This means that the weighted average of 2 different bundles is strictly preferred to the extreme bundles. Convex preferences may have flat spots, while strictly convex preference must have IC that are rounded. The preference for 2 goods that are perfect substitute are convex but not strictly convex. Okay. So this is where we just go through that. Next is marginal rate of substitution. Okay, and for this strictly convex preferences, indifference curve exhibit diminishing marginal rate of substitution. Okay, so what is marginal rate of substitution? The slope of an IC is known as marginal rate of substitution, but what is that? Okay, so we can explain it. 1 minute. First just mark this. With this paragraph we can go, or else you'll just leave this. This is somewhat important, so yeah. The name comes from the fact that the MRS measures the rate at which the consumer is willing to substitute one good for the other. Okay. Willing to substitute one good for the other. This is the meaning of marginal rate of substitution. So at what rate he is willing to substitute? That is marginal rate of substitution. Okay. Suppose that we take a little good one, that is delta x1. Consider that as the part. Okay. Then that's taken away from the consumer. The consumer is sacrificing that part. Then we give him delta x2. We are substituting this delta x1 by delta x2. Okay. it it is an amount that is sufficient to put him back on the IC, so that he is just as well off, like he is having the same satisfaction as before. That means this delta x2 can give this consumer same amount of satisfaction as delta x1 could give. Okay. We think of the ratio delta x2 by delta x1 as being the rate at which the consumer is willing to substitute good 2 for good 1. Okay. So for how much good 1, good 2 is how much good 2 needed, that is here. Now think of delta x1 as being a very small change, a marginal change. Then rate delta x2 by delta x1. Now think delta x1 as being a very small change, a very small change. So this rate measures the marginal rate of substitution of good 2 for good 1. As x1, delta x1 gets smaller and smaller and smaller. Delta x2 and x1 approaches the slope of the indifference curve. Like this. Okay. So this is the indifference curve. So this is the indifference curve, and this is the slope of the indifference curve. So how will we measure? What is slope first of all? It is the change, right? So here let me mark it like this. So from here to here, delta x2, that is x2 decreased. So change in x2 from here to here, that is the point is here now. First the bundle was here, then now it is here. So this is another change. This just x1 just changed to here, x2 just changed to here, and we mark this as the change. So this is the slope that can be marked as delta x2 by delta x1. That is the MRS. Okay. So the rate at which the consumer is just willing to substitute a little more consumption of good 2 for a little less consumption of good 1 is described here. And the MRS is typically a negative number. Why? So we have already seen the monotonic preferences imply IC curves must have a negative slope. Since MRS is the numerical measure of the slope of an IC, it will naturally be a negative number. Okay, and next, the marginal rate of substitution measures an interesting aspect of consumer's behavior. Suppose the consumer has a well-behaved preference, so like a preference that is monotonic and convex. So that is what well-behaved means. And he is currently consuming some bundle X. We now will offer him a trade. He can exchange good 1 for 2 or good 2 for 1 in any amount at a rate of exchange. Okay, here nothing is a free lunch, right? It's in a rate of exchange. There is a trade-off happening. So if the consumer gives up delta x1 units of good 1, he can get E. E means, so we'll denote the rate of exchange as E. So E delta x1 in turns according to the rate at which the exchange happens. So E delta x1 units of good 2. Or conversely, if he gives up delta x2 units of good 2, he can get delta x2 bar E units of good 1. That is, yes, exchange rate. According to the exchange rate, he will get delta x2's exchange rate. He will get good 1 according to that. So geometrically, we are offering the consumer an opportunity to move to any point along a line with slope minus e that passes through x bundle. So this is, I'll show it in a, so this is what it is. So here, this is the slope, and the consumer can move to anywhere in this slope. Okay, the exchange rate happens in this slope only. That is why it is minus e. Now we can ask what would the rate of exchange have to be in order for the consumer to want to stay put in X bundle. And here we will be like, there will be some points on that line that are preferred to X1 and X2. For this, we are preferring another points which are here. Thus there are above. Okay. And what should we do for this consumer to stay in the same line? He must not go up. The exchange line must be tangent to the IC curve. For that, the exchange line must be tangent to the IC curve. It must be like this. Okay. So the slope of the exchange line, that is minus e, must be the slope of the indifference curve. Okay. So that is it. So trading at an exchange rate means we are allowing the consumer to trade the goods at exchange rate E, which implies that the consumer can move along a line with slope minus E. Thus, the slope of the IC, the MRS, measures the rate at which the consumer is just on the margin of trading or not trading. At any rate of exchange other than the MRS, the consumer would want to trade one good for the other. But if the rate of exchange equals the MRS, the consumer wants to stay put. Okay. And we speak of the other interpretations of MRS. So slope of the IC measures the marginal willingness to pay. From this we can analyze, get that slope of the IC means how much the consumer is ready to give good to for some units of good 1. If good 2 represent the consumption of all other goods, the composite good theorem, and it is measured in dollars that you can spend on other goods, the 2 good theorem we have studied in the last class, okay. Then the marginal willingness to pay interpretation is very natural. The marginal rate of substitution, the MRS, of good 2 for good 1 is how many dollars you would just be willing to give up spending on the other goods in order to consume a little bit more good 1. Thus, the MRS measures the marginal willingness to give up dollars in order to consume a small amount more of good 1. But giving up those dollars are just like paying dollars in order to consume a little more of good 1. So, like if you have followed the other classes, this will be really easy. It's just saying about the composite good theorem. When it was, I'll write it if you forgot that. So when it was P1 x1 plus P2 x2 equals M, P1 x1, like x1 was a particular good. For example, it was milk. So the consumer was ready to spend P1 amount for the x1 units of milk. And P2, so x2, sorry, and x2 was all other goods other than milk where the consumer was ready to spend, where the consumer was ready to consume. So x2 denotes, represents all other goods other than the milk or the x1 where the consumer is ready to consume. That means x2 is not a particular good, it represents all other goods. So we can also say that x2 represents the money which the consumer is ready to spend on all other goods other than this milk or x1. Right? So we don't need to mention any P2 extra there. We can peg P2 to 1, like we can divide the whole equation by P2, then we can write P1 x1 plus x2, because x2 itself is the amount the consumer is ready to spend on the other goods, is equal to M. So this is what this interpretation says. Next, the marginal rate of substitution of good 2 for good 1 is how many dollars you would just be willing to give up spending on other goods in order to consume a little bit more of good 1. So here the MRS measures the marginal willingness to give up dollars in order to consume a small amount more of good 1. The same theory we are applying, the same concept to the willingness. Okay. Here instead of price we are calculating willingness. I mean we are using the concept of willingness. Next, if you use the marginal willingness to pay interpretations of this MRS, you should be careful to emphasize both the marginal and willingness aspects. Marginal willingness to pay interpretation. It is a new concept. Okay. MRS measures the amount of good 2 that one is willing to pay for a marginal amount of extra consumption of good 1. So, how much you actually have to pay for some given amount of extra consumption may be different than the amount you are willing to pay. How much you have to pay will depend on the price of the good in question. How much you are willing to pay doesn't depend on the price. It is determined by your preference. Similarly, how much you may be willing to pay for a large change in consumption may be different from how much you are willing to pay for a marginal change, a lesser change. How much you are actually end up buying of a good will depend on your preferences for that good and the prices that you face. Okay, according to your income. So how much you would be willing to pay for a small amount of extra of the good is a feature only of your preference. So that's what it is about. Next, if we speak of the behavior of MRS, so we have almost covered this chapter. So in the other interpretations we discussed all these parts, and next is behavior of the MRS. So for this perfect substitutes, indifference curves the highlighter got stuck. Fine, I'll use the dropper. So for the perfect substitutes, IC are characterized by the fact of MRS is constant at -1. So in the perfect substitutes, we remember the example of blue and red pencils. The consumer doesn't care the color, he just wants the number of pencils to be 20. Even if it is 2 blue pencils, 18 red pencils, or 5 blue pencils and 15 red pencils, he doesn't care, he just wants an altogether 20 pencils. So the MRS is a constant there, right? Altogether it ends up in 20 only. Whatever change or trade-off happens, it ends up in 20 only. So that is a constant there. So that is why we are having a slope of -1. The neutrals, like for them the MRS is everywhere, infinite. Okay. And perfect complements, the MRS would either be 0 or infinity. Nothing in between, okay. Next, we have already pointed out that the assumption of monotonicity implies the indifference curve must have a negative slope. So the MRS always involves reducing the consumption of one good, sacrificing one good to gain another. That is for the monotonic preferences. More is better. The case of convex indifference curve exhibits yet another kind of behavior for the MRS. For strictly convex indifference curve, the MRS, the slope of the IC, MRS means slope of the IC, decreases as we increase x1. Thus, IC exhibit a diminishing marginal rate of substitution. So I had said it in the beginning. So that's it. This chapter is done. We are done with the chapter. Okay. So these are some key points of the chapter. You can read it by yourself. This 4, okay? This will be very important. Questions can come revolving these 4 concepts. So just read it. We'll do all the questions and after the syllabus is covered. Thank you.